All right, hey everyone, Riley here from becomingelectrician.com. In these upcoming videos, we're going to be drawing on the screen and we will be doing some basic circuitry, okay? So if you are brand new, in your first year of schooling and you're confused with all that kind of stuff, we're going to be talking about basic circuits and what you really need to focus on as an electrician out there in the field, as a residential and commercial electrician. We are mainly focused on AC circuits, all right? There is also DC circuits. This is alternating current and direct current. But when you're first getting started, typically they are going to be teaching you about DC, okay? But as an electrician out there, you are going to be focused on AC. You're also going to be focused on parallel in the real world, okay? When we are pulling our wires, parallel allows us to get voltage to stay the same, which means we have 120 volts off, across all our devices in a typical normal scenario, like in our homes and stuff like that, okay? Okay, and then the other one is series, okay? So series is, for example, let's say we had a couple resistors in here, and so what you want to learn is parallel, your voltage is always the same. In series, your current is always the same, okay? So for example, if our circuit's going like this, and let's just say we had like 10 amps here. So 10 amps would be dropped across every single one of these electrical loads. And that's what I want to talk about before we go further, okay? We want to talk about electrical loads. So let's just go back a little bit. And so this right here is what you call an electrical load, all right? And so this could be a little bit confusing because this is a load. It's what consumes power. Over here is a power source, okay? So this is called our source. And so this power source, again, if we are out there in the field, this source is our panel, our electrical panel, or it comes from like the transformer. And essentially, it's being generated somewhere, like, either by water or, wind turbines, however it's generated, it comes into your electrical panel. And so this right here is the source. And typically, we have 120 volts off of one phase. And in a home, we would have 240 volts across two phases, for our ovens and stuff like that. But let's just keep it simple before we go further. So again, this is the source. This is providing our power. But when you're talking about a DC circuit, typically it will look like this, okay? They'll have this, and it's just like a battery. And then many times they'll be like, okay, it's 12 volts or however much like your actual battery is, okay? And then the same principles of series and parallel, all that stuff still applies. But okay, so let's just talk about an electrical load first. So the first thing you need to understand is when you hear the word purely resistive, it is special and it is unique in a sense that when we talk about Ohm's law, so first of all, whenever it comes to an electrical load in our circuit, so for example, imagine you had one here and you had one here, so this is R1, this is R2, this could be R3, okay? Whenever you are doing your test, always, always, always draw your T's, okay? And you might be like, well, what are these T's? So the T is Ohm's law. One sec, let's just do this one here. Okay. So Ohm's law is V-I-R. So V could also be E, all right? I is A, right? Your amperage. And then R is your ohms, okay? It's a little symbol like that, kind of like that, okay? So this is actually a triangle, and it's called Ohm's law. And before we go further into this, again, so when it comes to a resistive load, so a purely resistive load is something like a baseboard heater. So you're going to see it called a BBH out there. Baseboard heaters are still very, very common when it comes to condos and apartment buildings. If you notice, they always put baseboard heaters underneath windows, okay? It's to do that to create kind of like a shield so that when the cold comes through the window, the baseboard heater is kind of blocking that cold from coming in. And even if you go to like something like Walmart or whatever, as soon as you walk in, you'll notice that they have like an air curtain, right? They have like a fan that blows down, it blows down heat, and it's keeping the heat in the building. It's a very, very cool invention. Okay, so that's a baseboard heater, or it could be the incandescent light bulbs. So when we're talking about purely resistive electrical loads, which are consuming power, because again, let's say we have 120 volts here, comes into the circuit, this is drawing power. Again, it could be a baseboard heater, but again, this is a resistor. So when we see a resistor, it's very, very special and unique. and it has to be something like a baseboard heater or an incandescent light bulb. Again, nowadays we're starting to see LEDs, so they're really not 100% purely resistive, but the idea and the concept still kind of applies, all right? Now, you might be asking, well, then what is a load that isn't purely resistive, okay? And so you're going to start seeing things like inductors and capacitors, and in order to figure that out, we actually need to do Pythagorean Theorem. And you're going to discover in like your second and third year and fourth year of electrical that all you're trying to do most of the time is figure out this right here. You're trying to find the longest side of the triangle, the hypotenuse, and you're also trying to find the angle for what's called the power factor. And if the power factor is not 1, that means that you are essentially losing money, okay? In other words, what you're putting in is not what you're getting out. And again, I don't want to break this down. I don't want to get too much into this because if this video is strictly for beginners, this is much further on. But what I want to say is in the real field, when we are electricians and we're dealing with AC and we're dealing with parallel circuits, the engineers figure out all this technical stuff for us. When we go to school, we got to break it down. We have to understand it. But when we're out there in the field, we are really looking at the prints. We're looking at what's called equipment schedules. And we're also looking at the nameplates of our different pieces of equipment, okay? So again, that is a purely resistive load like a baseboard heater or an incandescent. And when we are using a purely resistive load, let's just kind of go back here. So when we are using a purely resistive load, that is where we can now, let's put our triangle, okay? Because again, whenever we have a load in our circuit, always put your triangle, okay? It's the easiest way to remember, VIR. And it's just this is just a math equation. So if you want to find current, so again, volts, current, resistance. If you want to find current, you just go volts divided by resistance, gives you current. It's just a math equation, okay? Imagine this wasn't here. So you just go voltage divided by resistance, and it gives you current. If you want to find resistance, imagine this isn't here. Voltage divided by current would give you resistance. If you want to find voltage, imagine this isn't here. So essentially, it's current times resistance gives you voltage. Okay, this is called Ohm's law. And when we have a purely resistive circuit, this can fully apply. When you have inductance and capacitance, that is again where you're going to have to start getting into these triangles, and you have to do Pythagorean theorem. So C equals A squared plus B squared. And again, we're not covering that at all in this video, but it's important for you to at least see this right now, because once you start getting into this in your schooling, you've seen this and you're like, okay, well, I understand it's coming. All right. So now before we go a little further into this video, I just want to talk about quickly on my website, I have prepared a couple articles for you guys. So let's just hop over now. So I'll get rid of this and we'll bring in the monitor or in the screen. So this video right here is how does a basic electrical circuit work, okay? And so I've already kind of written this up for you. Again, I always leave you guys articles on my website, but you can see we have a hot line and we have a neutral, and we also have a resistive load. And there is that Ohm's law, the triangle, voltage, amps, resistance. So whenever you have an electrical load, I'm telling you, always put your T. You always put your T, and I'm telling you, you will never screw up. Makes your life so easy. Just down here, I did Ohm's law. Okay, so on this article, you can see Ohm's law. I'm just going to back up a little bit here so you can see it better. And again, if you want to download my free book, again, it is right there for you guys as apprentice electricians. There's tons of valuable tips in there. But again, so I'm just telling you right here that Ohm's law, it's just like a math triangle, and it makes things a breeze. It's so easy. You just go volts divided by, current gives you resistance. And if you make that T, that's what the T is, okay? And I think that's it for this article. I break it down right there for you as well. Here's another upcoming article I have for you about what is an electrical load in circuitry, okay? So I already shared with you, an electrical load is something that consumes power. It could be like a light bulb, a motor, a TV or air conditioner, speakers, that you plug into the wall to listen to music. anything that is consuming power. And then we have our power source, which I'll talk about in just a second as well. But you can see that this is like a resistor, and this is like kind of like how they draw it. But remember, this is a purely resistive load, something like a baseboard heater or an incandescent light bulb. But typically most loads, like for example, if you're on your computer or stuff like that, that stuff is not purely resistive, and that's where we're going to have to get into Pythagorean theorem. Which we'll talk about in just a second. This is like a light bulb symbol, which you may see. But one thing to mention about light bulbs is back in the day, there were like, a lot of incandescent light bulbs, but, they're really inefficient. They just, they got really hot, and tungsten, the metal itself, when you apply electricity across it and it gets really hot, it gets bright. That's what tungsten does, right? Very, very cool. Whoever thought about that. But that's what an incandescent light bulb does. But nowadays we do have LED bulbs, and so technically, like, they're not 100% purely resistive. Here's like an inductor symbol. Now there are different styles of inductor symbols. This one is like an iron core. This is like the most common one I saw when I did my schooling. And then there's like a capacitance or a capacitor. Okay. There is one other article I want to quickly share with you. And again, this is all on my electrical website, becomingelectrician.com. In this article, I talked to you about volts, amps, resistance, and power. And so again, there is Pythagorean theorem. So let's go back to the drawing. So let's just give us a little example. And so again, if we have a power source here, I want to talk, from a real electrician's point of view. So if this is an AC circuit, typically they'll be like, it's like this, okay? And then what they'll do is, they'll say this right here is 120 volts, okay? And then what they'll say is this right here, this resistor, let's just say it is 10 ohms, okay? And what they're going to say is solve, all the values or something like that. So what you're going to do is you're going to put a T here, because this is across the, resistor 1, and then this is like the mains, right? On your actual power source. So you know that you have 120 volts. So 120 volts is right here. You also know you have 10 ohms. So there's 10 ohms, okay? And so because we only have one electrical load, this is a pretty simple circuit, right? And so in other words, we know that we have 120 volts here, okay? But for example, if they threw at you like another resistor for like R2, again, you're going to draw your T, but again, now you wouldn't have 120 volts there. They would have to give you the value of this resistor. Let's just say it's 5 ohms, okay? So you'd put 5 ohms there. And then what you would do is you would add up your resistors. So you'd actually have 15 ohms, which means that you'd have 15 ohms right here. Okay. And then whatever the value is right there. Okay. But let's go back. Let's keep it simple. We can do that one after. Okay. So this is where we're at. So on our main, we have 120 volts. The main is like the power source. So our power would be going like this, right? And then what happens is our resistor, and again, so this line right here is the hot, and then this line right here is the neutral in the real world. All right, so let me just break this here just so that doesn't add confusion, because again, so this right here is like your hot wire. It's like your black wire, okay? And then this right here, this is your white wire. It is your neutral. And so if the circuit is going, well, in AC, it's actually it's going this way, and then it's coming back, and then it's going this way, and then it's coming back, okay? But let's just say our circuit's going like this, and it's dropping fully across this resistor because there's no other electrical load in the way. There's no resistor this way. And if it was in parallel, we would actually still have 120 volts, because that's the benefit of parallel. We always keep the same voltage, which means all electrical equipment can still have that same potential, that same voltage, okay? So it's coming right here. We have 120 volts and we have 10 ohms. That's what our teacher told us. So if we pull up the calculator here, so I'm just going to go 120 volts divided by 10 ohms, okay, gives us 12 amps. And so we're going to come here and go 12 amps. And so now we can relay that information back here. And so we would have 12 amps. We have 10 ohms. Okay. So let's go back a little bit and let's just throw a curveball in there. So I'm just going to go back from the hot and the neutral and all this stuff. And what we will do is we will put a resistor in series. Okay. So what we will do is right here, actually let's add it here because we have resistor 1. We will add another one right here. We'll just say this one's R2. 2. And what we will say is this is, let's just say 5 ohms. Okay. So we know that this is 120 volts. So again, we're going to draw our T. We have 120 volts. And so now what we want to do is we have to find, the teacher might be asking, what is the current within the circuit? Okay. And how we're going to do that is we know that this is 10 ohms. And again, you see how easy it is when you draw your T's? This is 5 ohms. And so now what we're going to do is now we know we have 10 ohms and we have 5 ohms. We can add that together when we are in series, okay? So we have 15 ohms here, okay? And so now, again, let's just bring up our calculator. I already had it up. And so we have 120 volts divided by 15 ohms gives us 8 amps. All right? And so now, what I told you in a series circuit, amps never changes. So 8 amps is going all the way through the circuit the whole time, okay? So 8 amps is here. 8 amps is also here. So that's 80 volts. And this here, so 8 amps times 5 ohms is 40 volts. And what's 80 plus 40? 120. Boom. Okay? So whenever you draw your triangles, it is so easy. Okay, now let's just do a quick example of parallel, and I'm going to make it really easy just to really clarify about voltage, okay? So again, whenever you hear a parallel circuit in circuitry, the voltage is always the same, okay? So I'm just going to go back until we get rid of this resistor. Okay, so I just covered a series circuit with you. Now I want to cover a parallel circuit with you, okay? So again, in the real world as electricians, we're doing parallel circuits with AC. But when you're first getting started, they're going to start with a series circuit, DC, and all that kind of stuff. But in the real world, again, this is what we're looking at, AC and parallel. And so what I'm going to do is I'm just going to add in another electrical load. Again, these are purely resistive loads. So baseboard heaters, light, incandescent light bulbs, okay? And so what I'm going to do is I'm just going to put this as R2, okay? So this here is R2. And so the first thing you want to do is, again, you want to put all your T's, okay? This is going to help you out so much. Now, let's say our teacher is asking us for 2 values here, okay? I'll just kind of highlight this and see how it goes. Okay, let's say they're asking us for 2 values. They're asking us for, again, we have V, I, R. Let's say they're asking us for R total, and let's say they are asking us for current right here, all right? So in other words, they're asking us for this value, and they're asking us for this right here. So let's just write that up here. So that'd be RT, okay? And then I2, because for our second load, okay? So they're wanting to know those 2 values. So again, when it comes to these circuits, series and parallel, it's important to understand the basics of each of them. So in a series circuit, I stays the same, okay? In a series circuit, so current stays the same. In a parallel circuit, voltage stays the same, as well as if we had 4 amps in this line and we had 5 amps in this line, then what happens is when they get added right here, okay, because we have 5 amps right here, we have 4 amps right here, when they splice together, we have 9 amps. So in the real world, what you're actually looking at is you are looking at the hot wire. So this could be like your black wire. And what you're doing is you're splicing on. Okay. So now imagine this goes to like a light bulb. And so you still have 120 volts. So you'd have 120 volts right here because we know that we have 120 volts at our main. Okay. In a parallel circuit, voltage stays the same, which means we'd still have 120 volts there. If we come here, again, we are splicing on. So imagine this is like a junction box where you have 3 wires, right? You've brought in your home run. This would be your home run. This is now called branch circuitry. The green one is your branch circuitry. Now into the red one, this would be like another box somewhere else. This is branch circuitry. And so for example, if I just do this, like this one here would be like R3, right? And then again, you want to make your T, and this would have 120 volts. Now, what would change the voltage here is if we put a resistor right here, for example. Okay, so this is now in series, and we never wire this way as electricians when it comes to our basic homes where we are trying to power our plugs, because every single device like in your home, computer, TV, fridge, dishwasher, everything needs 120 volts, okay? So everything's in parallel. And so we're going to remove that resistor. Okay, so our teacher is asking us for resistance total, which is right here. And they're also asking us for current in the second load, which is right here, all right? So first of all, this resistive load, let's just say it is 20 ohms, okay? So I'm going to put 20 ohms right here. We're also going to put 10 ohms right here, okay? So this is the trick. You want to enter in the values as you know them. Now, when we go to our main, I told you when it comes to a parallel circuit, our voltage stays the same because again, there's no resistor right here. So in other words, we're splicing on, and so this is getting 120 volts right here. And then this is getting 120 volts right here. And so all you have to do is just do the math. And I told you that once we find this amperage and this amperage, which is going to come down here and come down here, what happens right here? I told you that they get added, okay? Which means that we will be able to find this value. Once you find this value, we can find this value, and then we will be done. We would be able to answer our test. And so that's the whole trick to these circuits, okay? So let me just use the calculator here. 120 divided by 10. So we have 12 amps. And then 120 divided by 20 ohms, okay? So now we have 6. So we have 6 amps. So we know we have 12 amps coming right here. We also know coming down here, we have 6 amps. So which means we have 18 amps. So 120 divided by 18 amps. What is it right there? Okay, so again, go back to the calculator. 120 divided by 18 amps. We have 6.67 ohms. There you go. So the biggest trick for you to understand is the principles of parallel and the principles of series circuits. I kept kind of always going back to those basics. In a series circuit, current's always the same. In a parallel circuit, voltage is always the same. And then we also know that when we have a different load, right, they all get added up. And so that's all I did. I knew I had 12 amps. I knew I had 6 amps, 18 amps, and that's how much resistance. Now, one thing that you'll notice is that you cannot add your resistance up like normally in a parallel circuit. And so that's where, a lot of people will go wrong. You have to actually inverse them. And so, for example, if I go to a different calculator here. Now, finding resistance in a parallel circuit is a little tricky. Again, like I just shared with you right there, right? You can see that our resistance is significantly lower than both of them. And that is another thing that you really have to look for if you're going to be writing your test. In a parallel circuit, on the total, it has to be less than any of them, okay? So you can see that 6.67 is less than 10, it's less than 20. So that's another thing that you have to keep in your mind. And once you understand all these different tricks, then you know how to always test your answer, okay? So I just want to quickly share with you how to find your answer through a calculator if you want to find the total resistance in this circuit, okay? So here is the trick. So you're going to go 1 divided by, and you're going to go bracket and then bracket, okay? Because now we have 2 equations in here. So I'm going to go 1 divided by 20. This is going to be for the second load. Okay, I'm going to close that bracket. Then we add them. Okay, then you have opening bracket and then 1 divided by 10, closing bracket, and I'm going to close it again. All right, and then I hit enter, and you're going to see we have that exact same answer. All right, so again, without getting super nerdy and stuff in this video, I wanted to just kind of break down how this works. And so if the teacher was asking you, what is the answer? So right here is 6.67 ohms, and the amps, I guess, is 6 amps. There you go. Okay. So if you guys like this video, make sure to leave a comment. If you have any other questions, I want to break down this stuff more into basic terms, but I just wanted to just kind of break down how does a basic circuit work, and then it kind of just got improvised into breaking down series and parallel because it's very important when you're out there learning. And again, I was always just referencing these principles. When it comes to series, amperage always stays the same, and your resistance can actually add up. So in a series circuit, we would actually have 30 ohms. But in a parallel circuit, I just showed you in the calculator, you had to do that kind of little funky inverse stuff, right? And so again, but then the rule is the actual total, the resistance has to be less than any single resistor. So if you had another one right here, and if it was 8 ohms, you knew that this still satisfies that kind of test. Okay, so once you understand these kind of basics, that's what's happening. But in the real world, like I was saying, we as electricians, we are using AC, okay? And we are also using parallel for, all our circuits. Whenever we are wiring our lights, whenever we are, running for plugs, our basic 14.2 to all our plugs and to all our lights, all that stuff is in parallel and it's all in AC. Again, when it comes to a resistor, this is a purely resistive load, okay? Such as like a baseboard heater and an incandescent light bulb. Therefore, this theory applies to this. But once we start going more technical with things like inductions or, inductors or capacitance, again, we are going to be looking at triangles and Pythagorean Theorem. And it's amazing how much we do this stuff. And all you're trying to figure out is right here, the hypotenuse, and you're trying to find out the angle for the power factor. But in a basic circuit, we just follow what's called Ohm's law. And that is the V, which could be E, but again, keep it simple. V for voltage, I, but again, if it was A, it's easier for amps, because most people out there as a real electrician, we talk about volts, we talk about amps, we talk about resistance, okay? One other thing I will quickly talk about is just the power triangle. So let's just draw another one here. So it's like this. So it'd be P, I, and then E, okay? But, it would be nice if it was just like voltage, but maybe I'll just do that, okay? So in the same way, if we want to find power, we are going to times amps and voltage to get power, which is watts, okay? If we want to find amperage, we just go watts divided by volts, gives us amperage. And if we want to find volts, we would just go power divided by amperage. And that's it, okay? So again, if you guys want to stay updated with the website, just visit the website, becominganelectrician.com/subscribe. You can download my free electrical book. I'm sure it's going to help you out and give you some inspiration out there. I know it can be really hard, especially, when you're an apprentice and your wage isn't as high yet, and you can feel inferior, or sometimes sometimes bosses aren't always the nicest. Or you can just subscribe here on YouTube, and when I release new videos, you will get them too. So thanks for checking out this video, and I'll talk to you in the next one.